Hello guys, and welcome to another Dancers online lecture. And we are going to actually look at the part 2 of phylogenetic tree that we discussed in the other lectures. Now in this lecture we are going to look at the part 2 of the phylogenetic tree. We've already discussed the phylogenetic tree, and now today I'm going to explain some basic concepts here that we didn't include in our previous phylogenetic tree. Now, supposing that this is your phylogenetic tree, which is a tree that will show you the ancestral relations between group of organisms that are under the studies, or even among the group of individuals that are under your studies. How distant are these groups of organisms? How are they diverged in time? When actually does this happen? We can find all these things. Now when you find all these things, you would like to explain it to the people in a kind of a diagram. That diagram is what we call the phylogenetic tree. Now this phylogenetic tree, it has its own basic concepts. Now when you look at the root of the tree, here we call the root, and each of these things we call them tips. Now if you look at the roots of the tree will represent the ancestor, the ancestral species, that is the founder of this particular all these lineages. So this will be their father, and these are the offsprings. Now every tip will explain a species, and every root here will explain the ancestors. That's the first concept that we need to put at the back of our mind. Now come to look at it here. These things will be the course of time. Here, this is the time it takes before this species here can be diverged into two different species. So here we call bifocation. That is the node. So this bifurcation, every bifurcation is a speciation event. Now every bifurcation will explain an event of speciation. Speciation, I'm sure you know what speciation is. Speciation is the radiation of a new species. How one species will diverge to form new species. Okay, sometimes it can happen. A single lineage can be divided into multiples of lineages that we call adaptive radiation. In this case here, we call it a speciation event, since in this particular time here, this species here has been split into two different lineages. Okay, so let's say this is the father, and this father, during the course of time, what happened here is it's divided into let's say John's and Peter's. So again, during the course of time, what happened is we see that this particular time, it takes from this time to this time for this single lineage to also be divided into two different lineages. So which is like in most cases we can see like two different species will radiate, and sometimes just one species will radiate from a particular bifurcation, just like in the case of here. Just a single lineage has been diverged here and it comes this way. So every bifurcation is an event of speciation, and this is what I want to tell you, and it's a basic concept that every phylogenetic or molecular systematic or biogeography students will be able to understand. In phylogenetic trees, every root will tell you the ancestor, and every bifurcation will tell you the event of speciation, and this term here will tell you the time it takes for this ancestral species, sister, to diverge into these two species. So every tip will give you what you call species. Now there is another thing. From these three, we can also explain certain concepts like monophyletic, paraphyletic, and polyphyletic terminologies. Monophyletic, as we know, in monophyletic groupings, all the descendants, they have emerged from just a single ancestor. Now when you look at these two species here, you will know that they have emerged from this as their common ancestor here. So which means these two would be called monophyletic. If you consider this point here, we can comfortably say that P, let's say P and Q, they are monophyletic groups since they have emerged from a closest common ancestor here. They share their closest common ancestor. They have all radiated from a single father. Now, if you want to consider a polyphyletic group here, or let me just go to paraphyletic before polyphyletic. Now, paraphyletic, which means all the descendants arises from the same common ancestor in the exception of just few members. It means if you have 7 members, let's say 6 of them would be like a monophyletic group and just one of them will be an exception, then we call it a paraphyletic. Now consider here, if you take this into consideration, let me use a different marker so that it will be visible. Now if you consider this, if you consider this point here into consideration here, now you take this point here, you will understand that if you consider this point here, P, Q, let's say A. Now P, Q, and A, if you consider this whole region here, you will understand that not all the members share very closest common ancestor, because this point here is not being shared with these two. These two share the closest common ancestor here. So this one is common ancestor is here. So you will understand that this is a paraphyletic. Some members are monophyletic and few members or one member is not part of that monophylecity. So we call it paraphyletic. For the polyphyletic, we will consider here that none of the members share the closest common ancestor. So when you consider here, then we can say that none of these members share the closest common ancestor. Okay, if you consider here this and this, they don't share the closest common ancestor. Here and here, they don't consider the closest common ancestor. So this is the basic concept that I want to put across, and I hope it is going to help. Watch, enjoy the video. Any doubt or question that you might have, get back to me via my YouTube channel or via my regular email address as I get back to you. Enjoy the video.